The sentence right there, volume deals with the amount of space an object contains. So, here is a cylinder. Remember, we are pretending it is perfectly circular all the way up. The surface area is everything that would be covered were I to dip this in a bucket of paint, right? The paint would then only cover the outside of this, yes? Inside is still empty, right? Yeah. So because the paint is only on the surface, it really technically only has, technically it has 3 dimensions. But as far as measuring's concerned, it only has 2 dimensions, yes? Because I could pop off this circle, I could pop off this circle, flatten out the rectangle, and the inside of those circles and rectangles would have no paint on them, yes? And we know that in reality, that paint indeed has 3 dimensions. It is a very, very, almost unmeasurable amount thick, correct? But from a math perspective, it only has 2 dimensions because it is flat. Does everybody understand? Volume, however, is the amount of space in the universe that this thing takes up. There is no other matter that can live in this space because this is in that space right now. That is volume. And because it covers 1, 2, 3 dimensions, volume is 3-dimensional, which is why it is measured in cubic units. So centimeters cubed, feet cubed. But we don't like to use distances if we can avoid it. So there is another whole bunch of measurements that have been invented to discuss volume. Sage. Of course I am. So, these are distances. You are all aware that a cubic foot would be 1 foot, 1 foot, and then 1 foot deep. But because we're used to using feet to measure linear distances, new measurements were invented for these things. But the math is all, as Sage says, exactly the same. Okay? So when we're talking about volume, we are usually talking about something, pretend this is solid, something solid taking up an amount of space in the universe. If we are talking about the amount of space inside, like how much coffee I could put in this cup, that is usually referred to as capacity. They are 2 different things, yes? Because the cup takes up more space in the universe than there is space inside for liquid, right? Because the cup is thick. Everybody cool? So usually, when we are discussing something solid, we leave it in this type of measurement. This is for solids. When we are talking about something, I'm going to erase this, liquid, we often use different measurements. And those are where liters, gallons, quarts, and things like that come into play. Everybody cool? For our class, we will mostly be using these. If I ever want you to change to liquid, I will always give you that, as Sage says, conversion factor. Everybody understand? And just to let you know how it works, you all know how a pop can holds 355 milliliters of pop, yes? You've all looked on the side of your pop can. You see it says 355 ml. Just to get your minds around it, if that was 1 centimeter, and that was 1 centimeter, and that was 1 centimeter, that equals 1 milliliter. You've all heard, you've watched hospital shows where they yell 10 cc's of Ativan stat, right? A cc is a milliliter, a cubic centimeter. If you know anything about motorcycles or engines, you hear about them being a certain amount of cc's. That's cubic centimeters or milliliters. It's the same thing. Nathan.
Why would the cubic centimeter only fit one cubic milliliter?
A milliliter is not cubic. A milliliter is automatically cubed because it's a measurement of volume. Okay? If we were to fill this with water and freeze it and cut it into centimeter cubes, there would be that many milliliters in here. This cup holds, I think, 800 milliliters. So if I were to freeze it solid and cut it into perfectly 1 centimeter cubes, there would be 800 little cubes. Okay? Everybody good? All right. So, all that is background. What we come to now is what volume actually is. So, this construction that I'm holding up right here, just the white thing. Right now, how many dimensions can you see on it? 2. What are those 2 dimensions? Length and width. So this is an area situation, yes? All right. Now, what were to happen if I were to take this 2-dimensional thing and repeat it over and over again? What would I get? I'd get this, wouldn't I? Which is what? 3-dimensional, and it is a prism. Does everybody understand? I started with a 2-dimensional shape, which was what? 2D, and it is a rectangle. When I repeated that rectangle, I got a rectangular prism. Everybody cool? So, this is 1 page, right? If I repeat it 550 times, I get a prism, correct? So, how does that apply to measurement? Well, you all, as Sage said, know this has a length and a width, right? Could we measure that length and width? Easily. We could easily, right? Could we measure its depth easily? Not easily. So, this area, the easy measurement we can get from it is 11 by 8 inches. Everybody cool? So that is 88 square inches, yes? When I repeat it once, now how many square inches do I have? 88 times 2. Agreed? 88 times 3. Agreed? If I repeat it 500 times, now I have 88 times this 500, right? But now this is easily measurable, isn't it? So I took that 88, and if I measured this, I would know the volume of this rectangular prism. Does everybody understand? Don't worry about the screen being blue. I'm not writing anything on. Everybody with me? So I took a shape I recognized, got its area, repeated that area until I had enough I could measure, and then I would know the volume of this. Everybody cool? How does that work for a cylinder? What's the shape I start with? A circle. And that circle repeats this many times, correct? What is the name given to the dimension that exists in the direction that the base repeats? Height. Even if I turn it this way, right? I start from the circle. This is the height. What if I turn it this way? Still the height. What if I put it on the ground? Is this still the height? Even though the actual height is this height. Everybody understand? That's the point, right? There's height and then there's height. And that's why it's confusing. Everybody cool? Yes. From a measurement perspective, height means from the ground to the top. From a geometry perspective, height is the direction that the basic shape repeats. Everybody cool? Okay. So knowing what you know now, if you know the area of the basic shape, yeah, it's going to be blue for a second. Takes if you know the area of the basic shape, whatever it is, and you repeat that basic shape, that is repeating in the direction of height, yes? So if you take the area of that basic shape and you repeat it, how many times? As far as the height goes, you get volume of any prism. Always. So what changes? The height is always the direction of that repetition, right? So what's the only thing that changes? The area of the basic shape. So if I add a triangular prism, like a Toblerone bar, what's the basic shape? Triangle. So if it was a triangle prism, it would be that is the base, and I would multiply by the height. The formula for that is, of course, base times height divided by 2. Pain in the ass, because there's height again, right? But it would be base times the height. What if it was a cylinder? It would be pi r squared times height. Agreed? What if it was a rectangle? It would be, what's this area? Length times width times height. Is everybody good? Now, if it was an octagonal pyramid, you have not been given the formula for an octagon, but there is one. You would use that formula for the octagon and then multiply it by the height. Is everybody cool? Yeah? It's easy, right? I mean, it makes sense. You start with a circle, you stack that circle up, you get a cylinder. Start with a square, you stack that circle up, you get a cube. Or square up, you get a cube. Yes? Yep. Not adding. You multiply it by the height. Everybody good? All right. Now, you're intelligent young people. Does a pyramid take up as much space as a prism? No, you know that, right? You're intelligent people. If I start with a rectangle and I build it up like a skyscraper, it takes up all that space in the universe, yes? How does a pyramid differ? It shrinks, right? So obviously, that pyramid takes up less space than a prism. No matter what, a pyramid, this will get me a pyramid if I divide by 3. Always. And that was found through experimentation. They took a prism. They could easily figure out what the volume of a prism was by starting with a square and building up. Then, back in the day before PlayStation, when people actually thought about stuff, what happens if I make it a pyramid? They chopped down the prism to a pyramid, measured its volume, and found out, lo and behold, that it is always a third of its related prism. Well, they don't have babies and sisters and brothers and stuff. So I guess if you need that, that's okay. So a cone would be 1/3 of the volume of what? A cylinder. Cylinder is pi r squared times h. So a cone is pi r squared times h divided by 3. Right? A triangular prism, base times height divided by 2 times height. Triangular pyramid, base times height divided by 2 times height divided by 3. Everybody good? Always. Now, let's take that and let's go back. This should have been the previous 4 questions. And those 4 questions are the cereal box, the pop can. I can't remember their exact number or exact pages, but they are these pages, starting on page 27. We did this one in class. Now this is a rectangular prism, yes? Which means if it's a rectangular prism, then one of the faces is a rectangle and that face repeats, right? Yeah. If I make the way it's standing is the way it would stand in our kitchen cupboards, right? So the way it would stand in our kitchen cupboards would make this the base. Do we all agree? And that rectangle repeats up to here, yes? Which makes this, and I'm going to change color, this the height. If we're going to do this the way it stands in our closet. Agreed? Now, when we did this earlier, we called this green one the length and width, so that made this the height. In a rectangular prism, does it matter? No, of course not. Because I could lie it down, stand it up, I could put it on the edge, right? My family likes cereal so much that we have them stacked vertically. So we can stack 2 boxes in the cupboard. So we're looking at what you guys would say is the top of the cereal box. Because there's so much damn cereal in my house, because my family all loves cereal. Not everybody has that much cereal in their house. You can probably stand the cereal in your house up normally. I cannot, due to the sheer volume of cereal in the house. So, if we are going to call this blue rectangle the base, and we know that the volume of every prism is the area of the base times the height, the only decision I have to make is decide what shape is my base. Agreed? Yes. Now, since it's all multiplying, order doesn't even matter with a rectangle, does it? So if we're going to call this the base, and I'm going to highlight it blue, then what numbers am I putting in for the area of the base? Yeah, which are 24 times 8. And then the height is always the direction it repeats, which is up here, which is how far? 40. And that's it. So we do 24 times 8 times 40. Which I can't do that in my head. So somebody's going to have their calculator out and get it. It's 320. Actually, I can. It's 640 and 7,680. Now, this is where we have to get technical. It is centimeters what? Cubed. Now, let's say you forget we're measuring in centimeters and you write inches cubed. Am I giving you 0? No, of course not. But if we were talking about an actual real life question, like how much, you'd have to buy to fill it up, or how much, something like that, then you got to have your numbers right. Everybody with me? Okay. Everybody's got it, right? It's just the area of the base times the height for every single prism. Is the cylinder a prism? Yes. Turn the page over. This was our square pyramid. What do we know about every single pyramid? Volume of a pyramid is what? It's the prism divided by 3, right? So if I know the volume of the prism, I can do this. What is the volume of the related prism? Well, it's going to be the area of the base, which in this case is a square. So length times width times what? The height. And then I'm going to divide by 3. What's the length and width of the base of this pyramid? 32 times 32. And what was the height of this pyramid? 65. And then what do I do with that whole answer? I divide it by 3. Now, some of your calculators will do this weirdly as we get more and more complicated. So be aware of what is going on. Okay? This is no problem. This one, if you do 32 times 32 times 65 divided by 3, you'll get the right answer. I can't do that in my head. You have to. What is it? 22,130? 22,186. And that would be, in this case, cubic feet. But again, it's the number that's important. Is everybody cool? Oh, we didn't divide by 3 yet, did we? Nobody divided by 3. So now divide by 3, and now what do we get? Oh, you did divide by 3. Okay. See, nobody told me. So that's the final answer. Is everybody good? Satjo. Oh, then 2 decimals, as always. Okay. Nathan.
So what we're doing here is pretending that the base is repeated.
Yes.
Like it would be a
Yeah.
square.
If this was its prism,
Which would be a cube.
it wouldn't be a cube. It would be a rectangular prism because it was 32 by 32 and then 65 up. This is what it would look like, right? And that would be 65. And that yellow square would go all the way up to the top. But it doesn't. Because it goes to a point, all of this space is empty. And it turns out that that is exactly 1/3 of what it would be if it was full all the way up. Yes, it is exact. It is always 1/3. No, we're going to do these 4 together. Then I'm going to be quiet for a minute, but I'm going to explain what you're going to do. Okay. Yeah. Yeah. Okay, if you did the front, it would be 40 times 24 times 8, wouldn't it? Does order matter? 5 times 2 is the same as 2 times 5, right? Okay. Okay. Is a cone a pyramid or a prism? It is a pyramid, but it is related to which prism? Cylinder. So the volume of a cone is the same as the volume of a cylinder divided by 3, right? And we know the volume of a cylinder is area of the base times the height, and then I'm going to divide by 3. What is the base of a cylinder? Circle. What is the formula for area of a circle? Pi r squared, and then I multiply that by what? The height, and then I do what to that whole answer? Divide by 3. That's all you have to do. So, what is the radius of my cone? No. Radius is 15 centimeters. What's the radius of my cone? 15. It says radius is 15 squared. And what is the height of my cone? Times 22. And what am I going to do to that whole answer? Divide by 3. Now remember, because pi is involved, there's 2 possible correct answers. One is 225 times 22, which I can't do in my head. 4,950 pi divided by 3. So that would be 1,650 pi. That's one answer. That's a math class answer. What's my answer in the real world? Pi button times 1650 to get 5,183.63. Is everybody cool? The math is always the same. It's either the area of the base times the height, or it's the area of the base times the height divided by 3. What makes your decision? Is it a prism or is it a pyramid? That's the only difference. Pyramids divide by 3, prisms don't. Riley. I don't care. I prefer that because then I don't have to get crazy with my calculator. To do that, I had to do one multiplication because I knew 15 squared in my head was 225 because I've got the first few memorized. All I had to do was 225 times 22. Even this division is not that hard to do in your head. Everybody cool? Yeah? All right. Let's do the last one. It's a cylinder. Is a cylinder a prism or a pyramid? Prism. So since it's a prism, it's always the area of the base times the height. Any division? What's the base of a cylinder? Circle. So it's pi r squared h. Pi, what's the r? 5 squared. What's the h? 20. 5 squared is 25. 25 times 20 is 500 pi. If I want the decimal answer, 500 times the pi button. It's going to be around 1500. Can everybody do volume? Of easy ones, right? Okay, now don't write down what I'm about to do. Okay, I just want you to look so you can think about it. Everybody cool? All right. If I gave you this shape, notice I am not saying a particular name. It's like a dumpster, yeah? Is that a prism? It is, isn't it? Why? What's the base? This repeats where? Right back there, yes? Yes. So, if this repeats, what does that make this shape? No, just what's colored. That makes it the base, doesn't it, Rylan? And since it repeats in that direction, what does that make that? The height. Now, is this a prism? And what's the volume of every single prism? Is area of the base times the height, correct? So in this thing that I have drawn here, it would be this blue area times the height, correct? So if I told you this thing was 7 meters, then if you knew that blue area, all you would have to do is multiply by 7, right? Well, how do I find that blue area? That's not a shape that we know, is it? Is that a shape that we know? That's a rectangle and a triangle. What would I do with those two numbers? Get the area of each and then do what? Add it together. Would that give me the area of the base? And if I took that and multiplied it by 7, would I have the volume of this weirdly shaped prism? Yes. So does shape even matter? As long as I can break it down and I recognize that the base is whatever I start from, because I called this a dumpster, so most of you immediately want to say this is the base because that's what's sitting on the ground, right? In reality, sure, that's the base. But in math, that can't be the base because that doesn't repeat. Is everybody good? It's not a pyramid. Pyramids come to a point. This does not come to a point. That blue shape repeats. Okay. Now, what if I told you I had a triangle pyramid? You're all used to seeing the pyramids of Egypt, which have 4 sides on the ground and go up, right? Okay. Well, this only has 3 sides on the ground and goes up. The bottom, the shape that repeats is what? A triangle. And the height goes straight up the middle, right? So if I know the area of this triangle, I would just multiply it by the height and divide by 3. Because it's still a pyramid, even though the bottom shape is weird. Everybody with me? And how do I find the shape of that? I would do base times height divided by 2. I would need to figure that out, maybe. What? No, just to find the area of the base. It's a triangle. So it's base times height divided by 2, right? That's why this gets tricky. Because base and height has so many different meanings all over the place, right? Some of you may remember this shape from about grade 6 or 7. The parallelogram, yes? Now, a parallelogram is just related to a rectangle, isn't it? If this was a straight up and down rectangle, it would be width and length, wouldn't it? But it's not. This we call base times height. So here again is base and height coming back to get in our way, right? Yeah, but then you're still looking for a base and a height.
No, like, put two, like make it isolate two separate triangles.
Do that and that?
Yeah.
Yeah, you could. And if you did that, this triangle over here would move over there, and you would still have base all the way along the bottom, and height would give me length and width. But again, when we build these formulas, we call it base times height. And then we go and we start talking about bases and heights and pyramids and prisms, even though the pyramid or prism runs that way instead of up and down. That is why this is confusing. The math isn't, because let's be honest, have we done anything more than multiply and add? We haven't, have we? When did we learn to multiply and add? Grade 3? So what makes this difficult? Remembering what is base, what is height, when it's a base, and when it's a height. Everybody good? All right, now listen, because it's going to get a little weird. When you all walked in, I eavesdrop on your conversations. It's impossible not to, because you all talk this loudly to each other, even when you're this far away. I have to hear you. It's impossible not to. And what I heard from a great deal of people was, I had a little bit of trouble at 30, 31, and 32. And then the person you were talking to, oh, I got number 6. Did you get number 6? Yeah, I didn't get number 6 at all. I need some more time with it. So here's what I'm going to do. By this time, this point in class, so about halfway through class tomorrow, I want 30 to 32 completed. Wait. 30 to 30, no. 30 to 32 is completed. And then there's no twist. We're going to spend a little bit of time now because we haven't talked about 2 other shapes. We spend a lot of time on pyramids and prisms because they're very closely related. Then I'm going to spend about 3 or 4 more minutes with these. And then you will notice on page 35 to 38, 35 to 38, these are volume and surface area questions. I want all of that done by sort of 3/4 of the way through tomorrow's class. You already had last night to do page 30 to 31. If you didn't do it, your work's piling up on you. Surprise, surprise. But before we go on, let's just take a quick moment. These questions, notice how I have just given you the formulas and not given you any space to show you how we build the formulas, because there is no way to show you in 2 dimensions how we built these formulas. Because spheres don't have a way to draw it in 2 dimensions. Because a sphere is a circle in the middle, stretched up, but not on a straight line like a pyramid. It's stretched up on a curvy line, right? So it's impossible to draw it out. Since a sphere is an infinite amount of circles, obviously pi is involved. Okay? So I just give you the formula. Please notice you already know what these things are. Radius is from the center of the sphere out to the edge, just like in a circle. And this one's a little harder to read. I don't know why we teach you this written this way. Because soon as you people see fractions, you run crying into the woods. What this should be written as is this. 4 pi r cubed, and then you take that whole answer and divide it by 3. That's way easier for you guys to deal with. Everybody understand? Now, I want to make sure of one other thing. We often deal with something called a hemisphere, which is, of course, half a sphere, yes? Now, mathematically speaking, how would I take this surface area and cut it in half? I would just divide by 2, wouldn't I? Which would get me 2 pi r squared, correct? Well, isn't 4 divided by 2 2? So I'd be okay, right? But there's a problem here. When I cut a sphere in half, what did I just make? I made another circle, didn't I? Is that new surface? Yeah. If this is a solid sphere and I cut it in half, that's new surface, right? So I need to add what? What did I just add? A single pi r squared. What is 2 pi r squareds plus 1 pi r squared? No. 2 pi r squareds and then 1 more pi r squared. 3 pi r squareds. That is the surface area of a solid hemisphere. I'll talk about that in a sec. What if it were a hollow hemisphere like a bowl? So I pick up, for example, this sphere, and we pretend that it's hollow inside, and I cut it in half. What's the surface area? Yeah. Would it be this? No, because it's hollow inside, right? It would be exactly the same, wouldn't it? Because it would be this part, and then inside that part. Does everybody understand? Some people do, some people don't. Let's do it with this. Pretend this is a perfect sphere, because it's clear inside, right? If I dipped this in paint, this paint would be everywhere, yes? That would be 4 pi r cubed, agreed? Now I'm going to cut it in half. Now I dip it in paint. Does the paint get in here? Is this the same as this? Yeah. So would the surface area change in a hollow hemisphere? No, because it's this and then it's repeated. So you wouldn't need to divide it by 2. Everybody cool? Okay. Now, what about volume? I'm going to cut it in half, aren't I? When you cut something in half, it's the same as multiplying by 1/2, isn't it? Right? What's 4 pi r cubed times 1? 4 pi r cubed. Over what's 3 times 2? 6. Would you ever leave that fraction? No, that's 2/3, isn't it? So the volume of a hemisphere is 2 pi r cubed over 3. That's the volume of a hemisphere. I'm too lazy to write sphere. Everybody with me? All right, now I'm going to shut up I don't bother doing number 1. It's a stupid question. I hate it. But let's talk about number 2. Because number 2 puts everything we've been doing, all about volume, into one question. So, before I start throwing in numbers, I got to know what I'm looking for, right? I got a cardboard box, and I'm filling it with 3 golf balls, yeah? What shape is a cardboard box? Rectangular prism, right? So it would look like this. Everyone agree? And it is 3 by 3 by 9, correct? What shape is a golf ball? A sphere. How many golf balls are going in there? 3. 1, 2, 3. Agreed? And those golf balls all have what radius? Well, the whole thing is 3 by 3. The balls go from edge to edge, so what's their radius? 1.5, right? So, I want to know how much empty space is left over. Now, this seems like a math class question, doesn't it? But it's not. Stuff comes in boxes, right? If you waste box space, did you pay for that box space? You didn't? You own a business and you package stuff and you get the box stuff free? Did you pay for that box stuff? What happens? Who actually pays for that box stuff? Me or the consumer? The consumer. So if I have to use extra packaging, do I have to raise my prices? Are you happy if I raise my prices? So somebody better know how to do this, right? Or you're going to pay more stuff for money, pay more money for stuff. So it actually is a real life question. It's disguised as being a math class question. So what is happening here? I want to know how much empty space I have. So what is actually happening here? I have a rectangular prism, right? And I have how many spheres? 3 spheres. What math will tell me what is left over? Subtraction. Now, what measurement do I care about? The surface area or the volume? So I need the volume of a rectangular prism minus the volume of 3 spheres. Agreed? What's the volume of a rectangular prism? Area of the base times the height. So it's LWH in a rectangular prism, right? What are the numbers that are going in there? 3 times 3 times 9. Yeah? Easy peasy. What's 3 times 3? 9. And 9 times 9? So I know I got 81 there. But I'm using up some of that space. One sphere is 4 pi r cubed over 3, correct? How many spheres do I have? 3. So I'm going to multiply that by 3, aren't I? What do I get to do with those 3's? Cancel them out. So really, I'm just subtracting 4 pi r cubed. 4 pi, what's r? 1.5 cubed. And now I can do it with my calculator, can't I? Since this is a real life question, do I need a real life measurement? Yes. So can I leave pi in there? No, because I'm actually building these things. I need to know how much wasted space there is. So this time, I actually have to use my calculator to find a number there. Not just pi. So everybody try to punch that in and get me that number.
Why do you use 4 pi?
Because that's the formula. 4 pi r cubed divided by 3. We get rid of the 3's because I have 3 golf balls. So 3 times that, the 3's cancel. That's why I wrote it out. You just jumped ahead to the next thing I want to talk about. Who has a number for me here? Sure. The whole thing. .59 centimeters cubed of wasted space. Everybody cool? It doesn't matter. You can put the whole thing in. Oh, then you're going to have to hit equals in there somewhere probably. You got to know how your machine works, Sam. Everybody's got a different calculator. It's one of the biggest pains in a math teacher's ass that everybody has a different calculator. And everybody's calculator works slightly differently. Wait till we get to the next unit. We're doing trig. It's going to make me take a pen and stab it in my eye. That's actually why I wear glasses, so I don't. It would be cubed because it's volume. Yeah. Everybody cool? All right. Now, listen. I said that Nathan gave something away. Look at what I did. Before I started doing anything with numbers, I wrote out the formulas. Why? Because I was able to then make it simpler to do by seeing this math. Everybody cool? I know that most of you will not do that. No matter how many times I show you and tell you it's a good idea, you won't do it. But I'm making a big deal out of it again. If you write out what you're going to do before you go to formulas and numbers and everything, it will always be easier. Okay? You have the rest of today and pretty much all day tomorrow to finish up to and including page 38. Do your best. If you have trouble, does it matter? No, because this is practice and you're going to see all the right answers anyway. When does it actually matter? Not till we get to this review and not until we get to a test. You're going to have a quiz in the way for more practice. Okay? No, don't bother with the basketball one. That's an algebra question as opposed to a volume question. And I'm going to review algebra at the very end of this unit because to do our next unit, trig, you have to be very good at algebra. Okay?
A lot of people say trig is their favorite unit.
I love trig. It's my favorite thing in math.
What is it Derek was talking about?
It allows you to measure stuff without measuring stuff. It's basically how we built this school. Yeah, trig. Well, yeah. Set joke. $35. Oh, don't draw the net? This is a net. A 2D version of a pyramid. You can't draw a net for a sphere because you can't draw it in 2D. Because the sphere is that. Right? You grab it in the middle and stretch and you've got a sphere. You can't draw it. It's a sphere with a radius of 25 meters. And I want the surface area, right?
So a net is like, you take it like...
It's what you break it down into. It's the plan. So a sphere with a radius, 4 pi r squared is the surface area of a sphere. Well, the radius is 25, so what goes there? And then you're done. Yeah. No. I didn't give you the answer. I wrote 4 pi r squared, which is the formula that I gave you right there. All I did was write that again. All right.